Hello, welcome to Maintenance Task Analysis in Windchill, making the digital thread work for you. My name is Christina Bergling, and I'm a Solutions Architect with Global Publishing Solutions, or GPSL. At GPSL, we are publishing and content management solutions experts. We like to take complex problems and come up with simple solutions. You can find out more about us on our website, gpsl.co. Before we talk about maintenance task analysis or impact analysis, let's talk about the problem. Why is working disconnected without a digital thread harder? And what does it cost you? Let's say we have a project with all their engineering data in PLM. However, that data is disconnected from all the service content downstream. Now this project needs to make a bid on a new contract with their product. So for the equipment, they can perform an internal assessment looking at what parts and CAD data need to be made or updated. From these numbers, they can create a rough order of magnitude estimate pretty easily. However, the request quote for the contract includes everything, all the deliverables. So this includes applicable service content, the PDFs, maybe the XML files. Without a digital thread, this estimate is a manual process and is largely just guessing. The project may look at the existing folders and make an estimate at the document level. This is probably not an estimate they can be too confident in. They might guess 100 work packages only for it to really be 200. This inaccurate estimate then ripples out. The resourcing for the project might be off. If they thought they needed one technical writer to produce 100 work packages over the course of the project, and now they find they actually need 200 work packages, they might not have enough staff to complete the work on time. This impacts the overall project timeline. If the service content is not done, the project is not done. Plus, without the digital thread, service content waits on engineering completion. If they were all working in the same system with workflows, the maintenance task analysis could be initiated earlier in the process, allowing the service content to be generated in tandem with the engineering development. When we talk about maintenance task analysis, what do we mean? In the aerospace and defense world, maintenance task analysis, or MTA, is the process of identifying the steps, spares, materials, tools, support equipment, personnel skill levels, everything necessary to complete a repair task. This includes both corrective and preventative maintenance. When an MTA is complete, it will include all the resources required to fully support a system. Maintenance task analysis often occurs with or without the digital thread. However, we're talking about how much easier and more useful it becomes when it can leverage connected data in project lifecycle workflows. So if you're managing your project in Windchill, you would have all the engineering data as part objects, and your initial MTA has been used to create the service content. For example, your sections or work packages detailing how to remove or replace a part, how to repair a part, how to perform scheduled preventative maintenance, and all the supporting illustrations that accompany those sections. Now, you can continue to use a tool in Windchill called the Impact Analysis Report to perform MTA for engineering changes. What this means is when you have a potential engineering change upstream, you are able to leverage the digital thread between your data in Windchill to see how it impacts service content downstream. This allows you to estimate the level of effort in a full product lifecycle chain to fully execute a change. When you know how many document sections and illustrations will need to be updated, you can add that estimate into the effort for the engineering change itself. When MTA is used for a typical change, the process initiates with a requirement. It might be a problem report from the field or a change request for the engineering design. First, the technical feasibility of the change needs to be assessed. Is this change possible? Can we make this change to the design and still have a functional product? Then there needs to be a cost-benefit analysis. How much will it cost to make the change? What benefits do we gain by making it? Do these benefits offset the cost? At this point, if the change is considered viable, we can use impact analysis to really see how much it would involve. We can use Windchill to see the downstream impacts of the upstream change. For example, if I replace this leg part, it impacts 12 document sections and 42 graphics. With that information, you can make a more inclusive, accurate level of effort estimate. That estimate is used to refine the cost-benefit analysis. The change control board can use that information to make a decisive go or no-go decision on the change. This webinar is somewhat a continuation of our previous webinar, running the digital thread from engineering to the operator and/or maintainer. If you did not catch that webinar, you can find the replay on our website, gpsl.co, under Events Past Webinars. We'll revisit this basic image from the digital thread webinar because the digital thread is what enables MTA and impact analysis in Windchill. To recap, the engineering CAD data enters the PLM system and is saved as part objects and the engineering bill of materials. A service bill of materials is created from and associated to that engineering bill of materials. Parts lists are also generated from the engineering bill of materials. We then associate the service content with the parts on the service bill of materials. These are connected back to the engineering bill of materials, which is connected all the way back to the engineering CAD. So when a change occurs in the engineering data, that trickles down the digital thread all the way to the content being delivered in the field. This connection and associativity between the data, this digital thread, is what allows us to use the impact analysis report to see how far engineering changes ripple downstream. The particular association that drives MTA and Windchill is the connection between the part object and the service content. The change, ECP, CR, problem report, what have you, initiates on the part object. That part object is associated with all the service content artifacts downstream that include it or are affected by it. So the information structures, publication structures, content sections or work packages, illustrations, and animations. From here, the impact analysis report lists all of these associated impacted downstream elements. The service content is on the receiving end of all this upstream workflow. When a change occurs upstream, it gets pushed to each of the associated objects. And one piece of content might be impacted by multiple parts. So a particular service content object might be associated with several part objects in the system. If you look at the structure here, it lists all of these upstream parts, anything that has been defined as affecting the content in this object. In Windchill, we will start with the part object. Let's say we're evaluating a change on the leg part. So we open the leg part object in Windchill and open the Structure tab. On the Structure tab, we see all the parts included in the leg. From the Reports menu, we select Impact Analysis Report. This opens a list of all affected downstream elements. Here we can see the leg part has been associated with an information group, with an illustration holder, the publication section, and with the textual content holder. This means it impacts an information structure, which is used to organize product data. It impacts a publication structure, which is a piece of a book that is published and delivered, a content section, which is the actual content, and then the illustration. If we go to the publication section instead, we can see the upstream parts. If we look on the Structure tab here, we see the Impacted By tab on the right. We can even run the same impact analysis report from here. This tab lists the parts that have been associated with this section. So if I right-click here and run the impact analysis report, I see that same list indicating which service content elements are impacted by the part. So these two ways show how all the pieces are connected by the digital thread. If maintenance task analysis is an existing and required part of the project lifecycle, how does the digital thread help? How can you make all the connected data work for you? When you perform MTA and Windchill, where the engineering and service data are associated, you're able to see the relationships between the pieces. You can open a part and see all the service content it impacts downstream. You're also able to look at a piece of service content and see all the parts that affect it. This information facilitates more accurate estimates. More accurate estimates provide better data to make improved contract bids and more informed change decisions. In short, it makes what you are already doing better and easier to accomplish. This has been Maintenance Task Analysis in Windchill, making the digital thread work for you. Thanks for listening. Please don't hesitate to reach out to us via our website, gpsl.co, with any questions. Thank you.